Welcome back. Let's move on to page 627. The three sets that I have written across the screen, set A, B, and C, might look unfamiliar to you at first, but look carefully. That's set notation. That's just another way to say the things that we've been working on. The first set, if I were to translate it for you, would be all the numbers smaller than 3. You see that inequality embedded in the set notation. We wrote this in interval notation as well. Let's take a moment to review that. All the numbers smaller than 3. We remember that this comma meant all the numbers. And if the smallest number goes first, the smallest number will be negative infinity. That always gets a round bracket, and 3 is the largest number. The bracket we give it, again a round bracket, means that we can get as close to 3 as we can without touching it. The next one written in set notation is all the numbers larger than -2, including -2. So in this case, -2 is the smallest number. It gets written first. Infinity will be the largest number. The brackets square, meaning that -2 is included, and round for infinity. Infinity always gets round because you can never quite reach infinity. For the last one, if we were to translate that into set notation, it would be all the numbers larger than 5. So we want all the numbers between 5, which is the smallest, and infinity, which is the largest. Again, infinity gets a round bracket, and a square bracket goes here because it's less than or equal to. For this, our goal is to find these things. We want to find, first off, A intersected with B. We want to find the next thing, which is A united with C. So when someone asks you to find these things, I guess the best place to start would be how they want their answer. The answer we'd like is going to be in set notation. Let's remember that set notation always goes bracket, number, comma, number, bracket. Bracket, number, comma, number, bracket. They're trying to find all the numbers that satisfy that equation. Let's get started. Before we had individual elements, and it was easy for us to use a Venn diagram. For this one, there's so many numbers that we'll need to use a number line to represent what we're talking about. Let's put some numbers on this number line. -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. I'll change colors of pens so that you can see exactly where things overlap. For set A, we want all the numbers between -infinity and 3. Well, -infinity is over here, and 3 is here. So I'll put a round bracket on 3, and I'll draw right on top of the line, all the way to -infinity. To graph the second one, we want all the numbers between -2 and infinity, including -2. So I'll put the square bracket here, and I'll draw all the way up to positive infinity, which is over here. Now, for the last one, set C, all the numbers larger than 5. That starts here, and it goes up to infinity. We're ready to answer Part A. Part A says, find the intersection those are all the and. Find the things that are in both A and B. Well, A is the pink and B is the green, so we see that the smallest number that both sets have in common is a 2. I'll write it here. The largest number both sets have in common is a 3. I'll write it there. That leaves the brackets. While the 2 is included, it's in both set A and B, the pink and the green. But 3, on the other hand, is not included. I need to make sure I write the comma to signify all the numbers in between. Now for the union of A and C. A is the pink, C is the blue. That looks like an OR statement. For a union, I see an example of something that's not in that union, and that's this little area right here. None of those points are in it. So I'm going to take my eraser. This answer is not in the form of a line segment. This answer instead is in the form of 2. To write the answer, we want all of the points that are in both. All of the points that are in A, the pink one, is negative infinity to 3, united with all of the points that are in A, which is 5 through infinity. There's the final answer for B. Take a look at it one more time, and I'd like you to take a moment to try skill practices 4 through 7 on page 627. When you're done with those, come back and we'll solve more compound inequalities.